Hi everyone. Today we're going to talk about Pipfile and pipenv. You're here at Python Frederick in August. And I am Matt Lehman, the organizer for Python Frederick. And I have a Twitter handle and a website up there if you're interested in following me in those places. So we're going to start with a key question today that I hope we'll be able to answer and feel pretty confident about when we're done, of how can I run my Python application in a consistent and safe environment. And so my claim is that we'll do that with a pip file. So I thought before we get into how and what this question is all about, we look at it from the aspect of the why. Why should we care that we run our applications in a consistent environment? And I think the short answer in my mind is to reduce bugs and reduce wasted time when our systems have problems. If you can be guaranteed that your application is in a consistent environment, then there's a whole category of bugs that just go away and that you don't have to deal with them. So it's just one avenue of or source of bugs that just evaporates. And it's a pretty big problem if you have it. If you have ever been in an environment where things are not repeatable or things are not built in a standard way, and you have different versions that are totally different hodgepodges of components, then you might have experienced some of the pain of what happens if you don't have a consistent environment. But we're gonna take a little bit of time to really make sure we really understand the problem and how I'm scoping this, and we're gonna define some terms. So I'm gonna start with the Python application piece of this. So we want to consider what kinds of applications are we talking about, and I want to pose this question to you guys. When you think of applications, what categories come into your mind? I can think of a few, and obviously I've thought about a few, but I'm wondering, like, what jumps out to you is what's an application for you?
I would say, honestly, at least for me, anything that's Python that's been developed enough to potentially be some sort of installable package. So obviously, like pip install Django or like I mentioned earlier, Troposphere. Anything that has gotten to the maturity level of being pip installed into a project, maybe not installed from the perspective of that package is saved on Python, but in your internal development for your company, and maybe pip install is a little too much, but is installed in such a way that you have to do things
Okay.
to get it to run.
So I'm just going to repeat a little bit just for the recording. So one definition is something that is installable in an environment. That's fair summary?
Yeah.
Cool. Any other thoughts? All right. Well, I broke it down into three categories for my mind that we'll think about. The first one was GUI applications in the traditional sense of you have a client machine. And I listed Dropbox here as the example, so because it is a Python application. So if you are a Dropbox user and you have the Dropbox client on your machine, that is Python code that is running. And the reason I've said not GUI apps here is because a traditional GUI app is usually either a gigantic thing that's been bundled into a big executable, sort of a single file, or it's been turned into some kind of installer that walks you through a process of getting all the pieces together. In either of those scenarios, there's a whole set of problems that come with that approach, which is a perfect approach for something that sits on a desktop software, but is a little bit out of scope for, I think, the problem that Pipfile and pipenv is solving. The second category that I was considering is command line applications, so CLI apps. And here I've listed HTTPy, which is a really awesome curl replacement. And I think that this sort of fits the bill in the sense that HTTP has requirements to make it work. Since it downloads stuff from the internet, it uses the very popular requests package to actually do those HTTP calls. And if you've ever used it, you'll notice that it colorizes your terminal so that you get a pretty output. So you get pretty JSON or pretty HTML rather than the standard black and white text that you might see from curl. So to do that, it uses a package called pigments, which is all about syntax highlighting of stuff. So it needs other things to have an environment. So I think it fits in our definition. And then the last area that I was considering was web applications. This is your Django system, your Django blog, whatever, Flash, Pyramid, any of these things fit into that category. And largely, I think this is the sweet spot because these systems can be huge, complicated systems that entire businesses run on. Instagram is running on Django, for example. And I'm sure they have lots of dependencies that they have to deal with. So these are really good fits for web apps. So that's what we're working with as our definition for Python application. Not so much desktop software, but definitely CLI or web applications. The second piece of this is environment. And I'm not going to poll you guys again to see what you think, but because this is a pretty broad term, and we can do this at a lot of different scales. The first aspect that I thought of is the physical environment, like your Amazon data center, your Google Cloud data center, whatever. That's actually really largely out of your control, right? If you were an Amazon S3 customer in the last few months, you would recognize how out of control you are in that scenario. Like there's just nothing you can do when that kind of stuff goes down. You're sort of at the whims unless you're doing a multi-cloud system. So I'm not considering the data center. I'm also not considering the operating system. So the set of packages, your Linux kernel, all of that stuff is not in scope for what Pipfile solves. It's really not in the wheelhouse of this kind of tool. And I'm not even considering shell environment very much. There's a little tiny bit which I can speak to a little later, but it's not the core of what the Pipfile is interested in. Naturally, we are considering Python itself and the other Python software that you need. So if your application is written in Python, but if you have these external dependencies like HTTP did with requests and pigments, that's the kind of software I'm talking about and what the environment is. The environment in that scenario was those external dependencies. And finally, I want to get to what we mean by consistent and safe. And I think this is the real crux of the heart of the problem. Without these few words in there, this question would be pretty silly. And the reason consistency and safeness is kind of difficult and what we'll be exploring in great depth is because of dependencies. We're all familiar with, or maybe most of us are familiar with the term dependency hell, where you're dealing with problems that occur because your dependencies are wreaking havoc on your environment because they don't match. So that's the big monster that we're trying to tackle. And before we look into how we can tackle that, let's look at where we are today in the Python ecosystem and how groups are normally handling it. So the current state of the art is to use a file that is conventionally named requirements.txt. There's nothing magical about this file name. And it is a file that is read as an input source to pip, which is the Python installing tool. And the format of a requirements text file can take a couple of forms. It's a very straightforward file that can either have package names with like version identifiers, or it can be simply the package name, in which case the tools like pip will try and install whatever the latest one is. So to do a quick demonstration of that, let's jump over to our trusty old terminal here, and we are going to take this requirements file, and all it has in it is requests. So I left it without any sort of specific version identifier. So I'm going to make a virtual environment which I'll call test 1. I'll clear it so we can see it. And I'm going to say pip install the requirements file. And it's hopefully going to go out and use cache things that I already got before the presentation. And now we have requests available for us to use. But when we did that, a lot more came along for the ride. So if we were to look at what is in the environment, you'll see certify, carded, IDNA, all that stuff is the extra things that came as dependencies on request itself, which we didn't specify. So we start to see little chinks in the armor of requirements, because we start to ask questions of, well, do I list versions or not? And to get a consistent environment. And there's other subtle things that happen of, have I listed all of the packages? Like if you were smart enough to list requests, do you also know all of its dependencies as well? So let's jump back over to our presentation.
I'm not sure if I was getting away with that version number. Doesn't pip force Semver?
Pip does not enforce Semver.
Oh, okay.
It is purely a conventional label. Yeah. There is a PEP, Python enhancement proposal, that talks about versioning in a consistent way, but not everybody follows it. So that's what a requirements file is today. And so let's talk a little bit about listing the versions or not. Like, what are the benefits of listing specific version identifiers? The first version, the first way that this can be done is with versions attached. So that was the beautiful soup equal 231 or whatever it was. And that's sometimes referred to as pinning. And this is the community's current attempt to provide this consistency, because if, in theory, you have pinned all your dependencies and included all of them, then what you install in your virtual environment should be all the software that you need. We'll see where this starts to get a little leaky and doesn't quite answer everything in a minute. The other version is what's considered unpinned dependencies. So that's where you just list the actual package that you need. And this is commonly done if you wanted to have developer tools where you don't really care if you're downloading the latest version of Flake 8 for lint checking or not. So why did I say attempts to provide consistency? What's really missing in this equation? And the answer that I've thought about is this issue of transitivity and the install requires. Now, I'm going to go into the subject a little in depth so we can be clear on it. When we consider what transitivity means, so it is this ABC relationship that you have here. So in this definition, C is a transitive relationship with B. So if you were to think of A as my application, and I depend on some external piece of software B, which depends on a third piece of software C, then we say that A and C have a transitive relationship. And this comes about because each package that you install, so considering B here, has an install requires in it that says, if I'm going to be installed, I need these things. And pip, that's what pip uses to actually look for things. Unless it's given a specific set of packages to install, like with a requirements file, pip is looking at what are your dependencies and making sure you have them all. So the trouble with this transitivity issue is that in a requirements file is that it's pretty easy to forget a package, or it's pretty easy to upgrade one of the packages like requests and find that you missed a package suddenly. For example, requests recently changed. They used to what's referred to as vendor all of their code. So their external dependencies, they put in one big gigantic bundle so that when you downloaded requests, you wouldn't actually have extra dependencies on top of that. But they made a recent change where some of that stuff got split out. So if your requirements file had requests as something that you required, and when they split it out and you bumped up to the next version where the split out happens, you would suddenly be missing these other dependencies like certify and IDNA and all that stuff, URL-lib3, etc. So that's a problem. So suddenly your requirements file is not capturing all of those extra things. And the reason it's a problem is because what you install on your machine is not exact. So you might have one version that gets installed at the first point in time that has a certain minor version, and another that happens a little bit later, even a couple days. And if that has a new release version and it hasn't been specified to the exact version number, then it could be a version greater. And as much as we want to depend on semantic versioning for making sure that the behavior of our applications is consistent, semantic versioning is not it's not a panacea. So we have stuff that can break your code even on little minor version updates. So I guess I'll pause for a second and make sure, because this is the crux of the problem, and I want to make sure that we understand what is the avenue for breakage here. Does this make sense?
I think if something's missing in your requirements file, but the thing you're installing knows its dependencies, won't it get installed anyway?
It will, but the key is
the version that you're expecting.
yes, not the version that you may be expecting. So that's where the opportunity for having an inconsistent environment arises from, and that's where weird seeming Heisen bugs come from, where your production environment might operate differently from your staging environment, and it might boil down to one has some minor version of package A versus some other minor version of package A. We also have this issue with what do we do about these developer tools? So I kind of said that we don't need to store specific versions of, say, Flake8 in our requirements file, and we just want to store it in there. But we don't really, it'd be nice to separate what we install in our production environment versus what we install in our development environment. Like, there's no reason for my production system to have a linter installed. It's just not necessary.
What's the other version of requirement text for developers? What's it usually called? The convention?
Yeah, the convention
There it
is requirements.dev.text, but I would say the community is not even fully consistent on this aspect of it. So this is a common one, but another common thing you might see is to have a requirements directory that lists out developer.text in that directory as your developer requirements. So it sort of breaks down. We don't have a consistent policy of what we do with development requirements. So I think this gets us to where the problem is fully defined. Transitivity is the big issue of what makes consistent environments hard, and requirements.text in its simplistic list form just doesn't solve it. And it doesn't solve it because it serves two masters. It can either be vague and say, here's just some packages that I want, or it can be specific and have all the packages, but then it's up to you to make sure that you include every single package if you're doing pinning. And that's just, it's hard for a variety of reasons. So here comes my claim. My claim is that the pip file is a superior alternative to requirements.text. And I'll start by saying that this is not a new idea. This is an implementation that comes about that has been seen in other languages. So if you are a Ruby developer, you've seen this with Bundler. If you do Rust, you know that Cargo does this. PHP has Composer. JavaScript has Yarn. And so it's a very common pattern. And the pattern is this. It splits out logical dependencies versus your full list of dependencies, which I might call like a manifest into two separate files. And it also includes the ability to have separate sections for production tools and developer tools. So kind of takes this one big blob and at least slices it two ways.
So it's some kind of structured file.
Mm-hmm. Yeah, and actually, which gets us to the Pipfile Anatomy, because that's important to understand. And here it is. So this is TOML. The reason they chose Tom's markup language is one I don't fully understand, but it's an INI style file, if you're familiar with those, with some extra niceties, I guess. But it breaks it down into sections of, and this is an example that I've trimmed down from a package that I write that's all about testing with the test anything protocol. So it's a little confusing that I have PyTest listed as a dependency when you might normally think of that as a developer dependency. But for the package that this works for, it is a true dependency. So sorry if there's confusion on that. But you can see that I've listed out Flake8 and Tox and Twine, which are all tools that I do for linting and test automation and actual secure uploading of PyPI packages. Those are things that a consumer of this package does not need. They're really more interested in making sure it works with their testing framework, which is why they need PyTest, and it uses the test anything protocol library tap.py.
So first thing is the double brackets up there, but the second thing is you're using quotes because of the period?
Yes. Yeah. Yep, that's correct. And I guess if that's probably just a specification of TOML that the value. It's kind of like if you have a dictionary, and you can use other unusual characters in a dictionary as long as you put them in strings. Although I guess Python is always they have to be quoted. You can't use bare. But if you came from like JavaScript land, for example, that's something that happens over there too.
But if you want to be consistent or satisfy your OCD, you could put everything in quotes.
You could, yeah. Yeah, I don't think there's any harm in doing that. So that's the structure of the logical view of this. So these are the pieces that are needed to make this package work, but it's missing something. This consistency element. The key thing that I've said is you have to specify your versions, and that's not in here. And at the start of when I was introducing Pipfile, you might have noticed that I mentioned having these things in separate files. And so the separate file is called a Pipfile Lock. And what it is a built version of your logical dependencies with all of the specifiers, version specifiers baked into it. And it's on top of that, it's been put in a machine readable format so that it's very easily parsable by computers. And I tried to hint at it by the inclusion of PyFlakes in the develop section. So this gets generated by a tool. You don't maintain this manually, and we'll see the tool in a little while. And so all of your dependencies get baked into this, not just the ones that you logically require. So this is where the transitive dependencies get captured. They get put in this file. Does that make sense? I'm seeing nodding. Good. Okay, so those are the two pieces that will be pretty critical to making this system work. But we're going to need a tool because, like I said, you don't want to manage this lock file yourself, because it could even have things like there's talk of including like SHA numbers in there and those sort of things to verify the integrity of packages, so that the stuff you download is not only the right version number, but making sure that it matches the SHA hash of the package from where you downloaded it from. So it's always the same down to like a mathematical clarity. So we're going to use pipenv as our tool for dealing with pip files.
So which came first? And is pip files a result of pipenv or the other way around? Or?
Yeah, we're really jiving today because I'm going to cover the history. That's in my notes here to cover the history of this. So the pip file came first. It was proposed by the Python Packaging Authority. I believe it might even still have an open issue on the pip tool on GitHub, something to the effect of requirements text 2.0 or something like that, which was a discussion of here are the big flaws in the requirements text and how are we going to deal with them. And so that's where the conversation started. Kenneth Wrights, the author of Request, is actually the one who's largely responsible for this whole system. He's the author of pipenv as well, and he's the one that ran with the Pipfile format and really made it a more concrete thing. I think it was in discussion for a while and didn't have an implementation, so it's hard to have a real discussion about how can we use this thing. So he was the one that provided this. And so the pipenv tool has a few features that we care about. And it actually has some interesting extra features. And the first one is this creation of virtual environments. So this is the one that I find interesting. A big problem for new Python developers is they'll often be told, don't install packages with your operating systems, in your operating system's package. I'm not even using the right term. In your operating system's
The system's version of Python.
Thank you, your system's version of Python, because that causes problems with the operating system. So you're encouraged to use this thing, virtual environments, but without necessarily being told what it is or how it works. And those of us in the know that it's basically a directory that includes all the extra stuff that's been set away from the system Python. But for someone who's new, that's a really confusing thing. And so pipenv tries to alleviate that newness problem, where it's creating a virtual environment for you, so that you don't even have to think about this stuff. So when you're installing packages with pipenv, you're really automatically getting a virtual environment, which is pretty cool. So the second core feature of pipenv is it will do an installation process where you can install with pipenv, and it will update your pip file as well when you do that installation. That's development packages or production packages. It's the same sort of process. And finally, we can use a pipenv to manage the lock file and do that generation. It's a simple command that reads your current pip file, looks at your virtual environment, and generates the lock file based on all that stuff. So I wanted to go from here and do a demonstration of pipenv in all of these commands in action to kind of hammer it home. So let's bring up our trusty terminal again, and I'm going to deactivate that virtual environment, and we will make a new one, and we'll call it pipenv test. And we'll go into that directory. So the first thing that we care about when working with pipenv, which I already have installed, so there's a little bit of a catch-22 here of, in order to get going, you need to have pipenv installed, but you kind of have to understand how to install packages. So I don't know. I don't really know how best to handle that problem, but we'll set that aside. We'll assume that you've managed to get pipenv installed. Yeah, right. And because the future of Python is Python 3, we're going to create a virtual environment. That's what this command does. Without any subcommand, we'll, whoops, I'm sorry. I didn't actually, would you look at that? It create how? How about that? Hold on a minute. So I think what it did is it went up a directory and looked and saw there was a requirements file. It's very curious. So we'll try this again. We'll go out of here. I did try this at home and did not have that trouble before, but I didn't do it from this directory. So, okay.
So it installs in the current directory?
No. Okay, there we go. That's more what I was expecting. You can see at the bottom here it says the virtual env location. So it has put there's a directory on my computer at .virtualenvs where all of these virtual envs will get dumped.
Are controlled by environment variable?
I presume so. I don't actually know directly, but it works for us for our purposes here today. So we're going to explore an example where we're just dealing with requests. So we'll say,
Random hash at the end?
oh, that's my Git plugin. That you're talking about that X? That.
No,
Oh, I'm sorry. Yes.
the viv test
Yep.
and dash.
Yeah, so you can have more than one virtual environment.
With the same name?
For the same package, I guess. So I have nothing in this directory right now except an empty pip file, which all it has is the required source section at the top. So if we say pipenv install requests, whoops, that's not right. Requests.
You could change the source to your own private.
Yes. Yeah, I think that's the key reason of why it's included. So if you have a dev.py instance or something, your own local package system in your...
one and then it would just roll through them all?
I think so. You're going to have to read the documentation on that one. But I believe the answer is yes.
He's got emojis.
He's got emojis, so it's pretty slick. And I think that's a little Easter egg because we installed requests and he's the author of requests. So, so good demo fodder. And so at this point, we now have our pip file, which has requests listed in the packages directory. And we're going to make a little application. And I'm going to import prettyprint, and I'm going to import requests. So prettyprint, if you don't know, is a standard library component. So it's not like I got that from somewhere magical. It's always there. And I'm going to call out to a service called HTTP bin, which is kind of like sort of like an echo service. It's not really doing a lot except verifying that you have a connection. And we will prettyprint, if I can type it, the response. Like so. So there's our whole app. This is really fairly silly, but it's a demonstration. So to use pipenv, there's a couple of ways to use it. And this is very, very much like bundler if you've tried Ruby out. So bundler has a way to, we're not in our virtual environment right now. We're external to it. Our shell has not been modified to have the paths that look for requests. So if I am right here and I say Python and I try to import requests, it's going to fail because we're not in the virtual environment. So in order to run the actual app using the virtual environment, we say pipenv run Python app. And there we go. So there's our response from httbin.org. It's just there's nothing exciting to see there except that we got data back from the internet. So that's the short and simple version of actually creating the pip file. So as you would be working with your app, you'd be installing packages, and rather than using pip install, you'd use pipenv install, and it would manage that for you of adding to the pip file and adding to your virtual environment at the same time.
So the Python, when you say run Python, is basically like a bash command?
Yeah,
it's directly you said Python app py and you had the virtual environment set up, the same thing would happen.
Mm-hmm. Yep. Yeah. So the other way that you can run pipenv is to use. There's another command that it's just the equivalent of the activate. If you have virtual env, it's activate, but running pipenv shell. And ignore all the gobbledygook. That's my personal Mac has a virtual env wrapper, so I use virtual env wrapper for work stuff. So that's just noise that you wouldn't see on another machine. But now, if I bring on Python, you probably didn't notice earlier, but my default Python on my box is version 2, and this is now version 3.6. And if we import requests, just to close the loop, we've got requests accessible. So that's all cool.
So when you exit, you're back where you started as far as...
Yeah, if I do an exit, I'm back to my...
Oh, so you have... okay, so you have to... When you exit the interpreter, you're still in
Yeah, so the shell command creates a subshell and puts you in it.
Okay.
That's what's happening. And that subshell has the modified path that happened like when you do activate on a normal virtual environment. Okay, so we've got that, and now I talked about having dev dependencies, so we'll do a quick example of that. So we'll go into our application, and Flake really hates when you have a ton of white space. So we're going to deliberately put a lint problem in there, and we're going to say pipenv install. But this time we're going to do with the -- dev flag, and we'll do flake 8. And it said it added it to dev packages. We can confirm by looking at the pip file. There it is. And then we can do pipenv run flake 8 on app. And there we go. Too many blank lines, which we would expect. So that generates the pip file. We've got manage dev and prod dependencies, if you want to look at it that way. And finally, though, we need one more command to close the loop, which is the pipenv lock command, which iterates through your pip file, looks at your virtual environment and it's all its dependencies and all that jazz, and generates the lock file. And this is something that you would want to commit to your version control. That's important, and we'll see why in just a second. So if we look at the Pipfile Lock, it's a bunch of JSON, which includes not only Flake 8, but these are all the dependencies for Flake 8 that we didn't have to list. These are all the dependencies for a request that we didn't have to list. It's all put in there. It's got CHAWs and a bunch of other stuff. So it's useful. Like I said, this is the machine readable part, so you really don't need to care that much about what's in here, but just to satisfy our curiosity, that's why it's there. So I'm gonna destroy our virtual environment with this -- remove command. So our virtual environment is gone. And so what we have left is our app and our pip file and our pip lock file. The virtual environment doesn't exist anymore. And I'm gonna do pipenv install. This time I'm gonna use the dev flag to install both our regular packages and our dev packages. And I'm gonna run it. So it realized that it had no virtual environment, and it found a pip file. And note the yellow line that's right above the progress bar, and that's key. Installing dependencies from the Pipfile Lock. So that's where we get our consistency guarantees. Because we had everything listed out in one gigantic manifest of all the dependencies with all the version numbers, that means that what I install and what Patrick installs would be the same thing. So that's the win.
Can you enforce the version of Python
Yes.
down to the minor?
Good question. I don't know that part, but I'm pretty sure you can.
So how do you tell that? How do you get that to show up in the pip file?
I don't know offhand, but I've seen it somewhere in either a lock file or a pip file, but I don't remember how to specify. Okay, so those are the features. So let's come back to our key question. Hopefully, we've sort of answered this now. The big piece that we really needed to figure out was the consistent and safe part for our environment, and we saw that Pipfile and the Pipfile Lock fixed the leaky transitive problem that was happening by not having every version pinned, and now it is. So this is something that you could integrate a Pipfile Lock into your deployment process, and I think your confidence about which packages are installed goes up pretty significantly over a requirements.txt based version. So that's what I have today. Thank you guys. Appreciate you listening. Hope you learned something. You want any questions, or we okay?
Yeah, I use pipenv a lot, and I'm wondering how this integrates with that, because what I like about pipenv is I can install just really easily another version of Python down to the minor version.
Mm-hmm.
But there's a lot of hooks, shims that you use as shims what he calls shims. And I don't know if they would work with this or not.
That's a good question. I'm not actually super familiar with that tool. So it's like a Python version manager? Is that what it is?
Yeah, it's like, it's modeled after the Ruby one.
Yeah, okay.
And, it's pretty slick, and has basic commands, you know, like pipenv shell, and then boom, I'm in that version of Python, or I could set it up to where I could say Python pipenv local if I'm sending in a directory and I want to pop to local. So I say pipenv local in the version of Python when I'm in that directory, and then when I leave the directory, I'm back to where I was. But if I enter the directory, it activates. There's all kinds of useful things.
That's cool. I will say,
If these work together, that would be awesome.
yeah, I will say pipenv is a fairly young tool. So integrations with other tools like a version manager, I don't think that they exist today, but I would foresee that happening in the future, especially if this gets really picked up by the community. I think the bigger win is probably the Pipfile and the Pipfile Lock itself, and because there's an argument, I considered using this for work, for example, and we at work deal with Ansible and creating virtual environments through Ansible scripts. And so I don't necessarily have the need to create the virtual environment through pipenv like it does, but it would be nice to be able to say, point pip at a pip file and install from the Pipfile lock when I'm doing a deployment. And that is one of the things where, like right now, there's the -r flag on pip for if you're installing a requirements text file. I believe there's discussion of adding like a -p flag for doing it from a pip file.
That was my next question. Pip supports the pip file.
Right. Yeah. So the pipenv is like an extra nice set of layer on top that if you don't want to have to manage a virtual environment, but for those of us that are in a scenario where we might need that would be a nice thing to have. But like I said, it's an age thing. It just hasn't been fully picked up. So we'll see. Any other questions? All right. Thanks very much.